Hello everyone, my name is Nail. Today we are going to talk about the evolution of RAG applications. I'm a machine learning engineer at Ardeo, and sometimes I'm tech lead, sometimes I'm a machine learning engineer, it depends on the use case. In case you, for some reason, you don't know what the Ardeo company is, but I hope you know, but in fact it's the French holding company. The most well-known brand is the Leroy Merlin. And we are presented in 21 countries, quite a huge company. Before I worked in Russia in that company, so now I'm working in France. Today's agenda is we're going to talk about the RAG itself, what it is, in case you don't know. How do we evaluate RAG, common metrics, the ways to evaluate, what kind of frameworks we can use for it. And some Ardeo's insights. How do we use RAG? How do we evaluate RAG? Some takeaways. So the first question: do you know what RAG is? Like, can you at least okay? So you know what is RAG, and maybe you also try to create a POC with RAG, or maybe even put something on production. Okay, several guys. So for those who don't know what is RAG, I will start with some entry-level slides, like just to explain why we use RAG, what it's useful, what it's not, etc., etc. When it happens to talking about the amount of data, usually we operate with the size of the Wikipedia. It's like around 5 billion of words. It's like quite huge amount of words. It's like our entire knowledge of the world. When it comes to the LLMs. In fact, it's like 3,000 times bigger than the knowledge of the Wikipedia. It means that LLMs, they learned a lot. But the problem with the LLMs is that they didn't learn nothing about your entire documentation of the company, right? So if you will try to ask anything about what's happening in my company, how to do something like how to order a computer for myself, it won't be able to answer because it just didn't read anything from your internal knowledge. And usually it happens like if you have some questions, you go to your colleagues, your experts, asking the questions. Hopefully they know how to answer you. And hopefully they, from time to time, they put their knowledge inside the documentation. So they take their piece of brain and dump it into the Gitbook, Notion, Confluence. And it simplifies a bit the process. So now you can read documentation. Of course, it takes a lot of time since you need to search for it. And this is the place when the RAG becoming useful. Basically, it's the way to provide to large language models the access to the external knowledge. In this scenario, it's just the internal documentation of your company. Sometimes it could be something even better, cooler. You can see there is a different types of usage of the RAG. You can have internal company, as we just discussed. You can talk. You can create the customer support service. Imagine you calling to the call center and you're asking how to return my package because it's not the products are not fitting to me. All that questions that are directly related to the internal knowledge of the company. And basically, when it comes to RAG, it's the huge black box which contains of two main subblocks. The first one is the retrieval part. The retrieval part, it talks to some database. Your task is to take all your documentation you want to use in your RAG and put inside this database. We will not go into details how it works, just because it's not the topic of this today's talk. And the second block is the generator part. So basically, the idea is that you search for relevant context in your database. You take this context, you take the question of the user, and give it to LLM, hoping that LLM will realize that this is the question about these documents and will try to answer your question. So basically, this is how RAG works. The problem is that no, it's not the problem. The cool thing is that to create your first POC, it's quite easy. If you look at the amount of frameworks that appeared in the last 3 years, there is hundreds of different frameworks saying that you can build your own RAG in a few minutes, and you don't even need a data scientist to create your POC. The problem is that when it comes to the production, it becomes way harder. Why? Because you may probably already used ChatGPT, and each time you're asking the same question, it may generate different responses. It just because the LLM is still probabilistic model, it's a bit of black box. There is a lot of situations when it hallucinates. Probably you already heard about the use case when the lawyer tried to use the ChatGPT in the court, and it faked some facts. So it's a bit pity. There is a situation when you can trick any LLM-based application. Like this is the scenario when the guy managed to buy a car for $1, just because it's quite easy to talk to ChatGPT to create a huge context and start to trick it a bit. So this is the part. When it comes to that, it's very important to have evaluation of the RAG. So before putting something in production, you should be sure that you won't have that kind of situations that we just saw. Of course, you can start to read all the responses it gives. You can try yourself, imagine different questions. You can pose it to the RAG. You can check how it answers, but it won't scale. Like you can do it once, maybe, but it won't be like reliable. It won't be scalable. And the cool thing is that there is certain papers that are saying that you can use another LLM to judge the RAG. Like you using one LLM to judge another LLM, evaluating like is this responses are good or not. And if you want to use another LLM to judge the another LLM, the first step you would have is creating your good data set. And when it comes to data set, there is a lot of open source data sets that you can take from the internet, allowing you to evaluate any RAG. But the problem is that they are not relevant to your certain use case. So it's important to craft. Maybe you already have this data set, maybe you can craft it manually. Usually it comes that you need to have user question, answer, and relevant documentation where this answer could be inferred from. When you have this data set, you can go to the next step is picking right metrics. There is two types of metrics. The one type of metrics are focusing on the RAG retrieval part. So it's the part just to evaluate how well your RAG is dealing with searching of the relevant documents. And the second part is how well your RAG is generating responses. So we are going to deep in the technology. So there's like fun part is almost finished. Sorry for that. There is 4 main metrics. The first one is the context recall. The context recall measuring how well you retrieve relevant documentation. Like, are you able to retrieve all the relevant information to answer any question? And usually it happens like you have a ground truth from your data set. You ask LLM to split this ground truth into the different statements. And then you're checking if this statement exists in the document that you just retrieved. For example, in that scenario, we have 3 statements, and only 2 of these statements exist in the documents. It means that we can calculate our context recall, saying that the context recall will be 2 divided by 3. This is the metric we can get for that particular question. So then we can run this metric over all of our questions, and then create an average or a median of the metric. The second one is the context precision. If you work with data science, you can recall that they sound the same as in data science, like you have recall and precision, but it's a bit different. The precision is focusing more on how well you rank your documents. It penalizes you if you, for example, you retrieve like 10 documents that may contain the answer for your question, and if your right documents are very in the bottom, the metric will penalize your system, so you can tune your system to make the metric higher, better, just ranking better the retrieved documents. In that scenario, like we can see that there is a bit complex computation. If you want, you can see these slides a bit later, but this is just the formula how you can calculate the context precision. Then we have the faithfulness is the third metric, but it only focusing on the generation part. The faithfulness means how much bullshit things your LLM putting in the answer. When I'm saying that, I mean how much statements on the answer is just taken out of nowhere. It's like purely hallucinates. In that scenario, imagine you have your generated response. You have 3 statements in it, and only 2 of the statements exist in the retrieved documents. So it means that the third one is just taken out of nowhere. In the production scenarios, it's like very important to not to have that kind of situations. And the last metric is the answer relevancy. It's as you can understand from the name of the answer relevancy, it means just how relevant your answer to the actual user's question. To measure the relevancy, you split your response in statements again, and then for each of the statement, you're just asking LLM, is this relevant or not, and then you can calculate the overall relevancy of the entire response. Yeah, so now we know how to measure. What do we want to measure? How do we want to evaluate our RAG application? Now it's time to pick the right framework. Of course, you can build your framework, your own framework. You can spend some time build something from the scratch. But maybe as a good first point, you can take an existing framework and start with it. We took the ADO. We took top 3 most popular frameworks. It's Ragas, Giscard, and DeepEval. From the chart, it's the chart of the stars on the GitHub. You can see that actually they becoming more and more popular just the last year. So it's just the beginning of the hype of the RAGs and the evolution of the RAGs. So people get so that it's very important to evaluate RAGs before putting the application into the production. And I would just propose you to have a look at the evaluation of these RAG frameworks we did. So we just try to assess and pick the best application, the best framework from these 3. We start from Ragas for the task of the dataset generation. So it happens that usually when you want to create your RAG and evaluate it, you don't have a dataset. But these frameworks, they provide the possibility to generate your own dataset, like synthetic one. So you provide your own documents. You fit this framework with your own documents, and it tries to generate questions and answers based on your documentation. So then you can use it to test your own RAG. In case of Ragas, it's quite nice framework. It allows you to cover all the basic scenarios. It can allow you to generate different types of questions. The main problem is that we try to use it in our use case. You can adapt question generation for your particular scenario. You can provide personas. It's like you can say that I'm building the data set for that use case. The person who will be asking the question is, for instance, the customer of the store. You try to adapt the question that generated for that persona. You can provide some different personas like professional customer, amateur customer, etc., etc. The problem is that I tried to generate like 200 of different samples from the data set, and only 56 of them was relevant. So all the other was a bit not that good in terms of quality. When it comes to Giscard, it's quite nice framework. The only missing point is that it's very, very slow. I tried to guess why it's that slow. I checked the source code of the framework itself. In fact, they are not using the async calls. They are not parallelizing the execution. So you can wait like 15, 30 minutes, and sometimes it could fail after 30 minutes of running. And then you need to rerun. It's very expensive. We decided not to use the Giscard. Even it's providing a lot of different question types. It allows to customize the generation. You can provide your own prompts. The third one is DeepEval. Me personally, I liked this framework mostly. The main power feature of the DeepEval is that you can assess the quality of generated questions by itself. It can ask another LLM to assess each generated sample. In case the sample is not good, you try to regenerate it. You can also provide some different strategies of regenerating samples. Quite powerful framework, so we ended up with it. So when I provide 200 of when I asked for 200 of the samples, it generated like 120. So it just means that you need to spend less and less time on manually verifying what's happening during the generation. You don't need to regenerate more and more your dataset. The second part of using the framework is evaluation, of course.
I have just a question on the slide before.
Yeah.
Isn't it faster to create your own dataset manually rather than using this framework that could be biased by the LLM weights?
Sure, you can create, and we have scenarios on ADEO where when people creating their own. The problem is that when it comes to ADEO, you would need to create that amount of datasets, the amount of business units you have. Let's say currently we're building the RAG for France, then we are going to build it for Italy, Spain, and other countries. And then you need to be an expert of that languages, or you need to ask. Yeah. So when you need to do this once, it works well. When you need to scale it, sometimes it might be tricky. So you can try to optimize it, hoping that it will be okay.
The only thing I'm worried is that because it's generated by LLM, it's by nature biased compared to human reasoning, and the thing you are trying to test is by default from LLM, so it's like it's inception.
Yeah. It's like, but in fact, it takes your documentation. So basically, you're providing your docs. You try to adapt the generation like to be unbiased. Like you can provide your, like in case of RAGAS, you can provide the persona, saying that the persona who's asking the question is like generic customer of Leroy Merlin. You can say that he's interested in that. You try to unbias it, but you're right that it will be biased. So that's why you will need to have your manual validation to see is this data set is right or not. But I would propose to ask questions a bit later since we can go out of the time. So the evaluation part, the most important one, in fact, there is RAGAS. I will go a bit faster on that slides. In case of RAGAS, quite nice. It covers all the basic scenarios. It has all these free metrics, even more. It works fast. The only cons is that it does not provide any reporting. You can get the result of evaluation, but there is no explanation of why is that particular metric is looking like this. In case of Giscard, it works very slow. Like you are also waiting for 30 minutes to compute your evaluations, but at least it provides you a nice charts. Like it generates HTML file, so you can see like summary of your metrics, etc., etc. The funny fact is that the Giscard, they just decided to take the RAGAS metrics and wrapped it, so they don't develop their evaluation by themselves. And the DeepEval, one more time, is the most powerful one. It provides you a lot of different metrics. You can create your own metrics with GEval and the DIG customizations. I won't go into details. I just make you know that there's like tons of different ways to create your own metrics, even more powerful that we just saw before. So in fact, we ended up with the DeepEval for both for dataset generation and RAG evaluation. When it comes to how do we use it in ADEO, we try to build the evaluation pipeline. So it's a pipeline that each time we provide any change on the RAG app, like will it be we play it with different databases for retrieval parts. We play it with different strategies of retrieving, searching the documents. In fact, it's very, very nice to be able to see how it affects on your metrics, because at the beginning, when we just started to build the app, we had a lot of different ideas on how we can improve the retrieval part. For instance, when you receive a question from the customer, you can ask LLM to rephrase this question to generate like 3 more sub-questions. In case customer provides some very unclear question or maybe too much complex question, so you can ask LLM. So we had the idea to implement this thing. We started to test it, and we realized that you don't need to do that if you're just increasing the size, the amount of documents you retrieve at once. Like instead of spending more 2 seconds on the retrieval part when you need to rephrase, we just increase the size of the amount of documents we retrieve. Instead of 3 documents, we start to retrieve 10 documents and battery rank it. So it covered this gap of liking the good retrieve documents. So just a bit more details how it works inside. We have a step that loads dataset from Object Store. Object Store is GCS where we store our pre-generated dataset. So we load it. For each sample of dataset, we retrieve relevant documents. Then we generate responses, and then we can evaluate both parts, retrieval part and the generator part. If you're changing only retrieval part, you can test only retrieval part, just switching off the generator evaluator to not to spend much money on LLM, etc., etc. So in fact, we ended up with the ZenML as the framework to create the pipeline itself. We're using MLflow to log every metric we have. There is one more part I didn't talk to you because we just discussed the way to evaluate RAG application in offline before deployment, but we also have a Datadog where we send all the traces. It's the traces of what's happening inside the RAG, how it goes from the block to block from the step to step, and what it generates in between. It's very interesting to see what's happening inside. You can measure the time it spends for each request. It's not an advertisement of Datadog, but there is also evaluation inside, so you can check in real time, like it can evaluate your each request. Maybe important one takeaway when we run the evaluation using this the DeepEval framework. Even with the good framework, it happens that each time you run the evaluation, the same data set, it generates a bit biased, a bit different results. So we ended up with running it 3 times in a row, and then taking an average, just being sure that at least 2 or 3 times it's showing us a good result. So we are taking the average. When it comes to how it looks like, we have a beautiful ZenML pipeline that is on the left, and we have some dashboards of the MLflow. Like we have different runs. We just try to put some information, what's the run about, what we changed. Did we change the database on something on the database side? Did we change the prompts or something else? And then you can see the given input and the reasoning of the framework, why the score is like, for example, it says that for the first input, the score is 1, and then it tried to explain why it put 1. It's quite nice to have this when you try to debug reason evaluation doesn't work. That's it. So it's time for questions.